So thank you for coming to the late show. My name is Johansen, and I'll be talking to you about Datomic today. So who has heard about Datomic before? A few of you. So Datomic is a fairly new, or several years actually, but it's a newish database that has a lot of unique and quite interesting features. It's sometimes referred to as a append-only database, so it only accumulates data over time. It never deletes data unless you explicitly tell it to. And it has an interesting architecture that allows you to independently scale reads and writes. You can query historical data. You can query across multiple databases. And it has a really nice and flexible schema at the bottom. So hopefully, before you leave this room, you'll have a working understanding of what Datomic is and what you might want to use it for. So my name is Johansen. Like I said, I work as a developer for Datomic, which is a consultancy here in Oslo. And my experience with Datomic is somewhat limited. I learned it last year. So like my abstract promised you some juicy details on my dieting habits. So I have a text file that I've been maintaining for 7 years with my family's dinners. So last year I decided to put that into a database so I could gain some insight on what's going on, like trends and stuff. And then since January of this year, I've been working with this company, append-only, which has built their service on top of Datomic. So I've actually now worked with it on a daily basis in production for 6 months. So I'm by no means an expert, but at least I've worked with it enough to have a working understanding of how to use it well and where it shines and what some of its limitations are. Right, so that's me. This is the Datomic logo. I'm a hands-on guy, so I like concrete stuff. So I'll be focusing on the data modeling capabilities of Datomic and the practicalities of working with it as a developer. And I'll be doing that against the live database with some queries, and so we can explore it together. That's the way I like to do things. But before I do that, I think it's interesting to discuss the architecture a little bit because it differs quite a lot from most databases you've probably ever used. Whenever you tell someone that Datomic is a append-only database, it never deletes data, invariably the first question or remark back is like, that doesn't scale. Who can afford to keep all their data around forever, right? And this is one example of a system that does that for you, and people use this without hesitation, right? And even I read that Microsoft recently put 300 gigs of code into Git, so you can have this historical model and still have it scale. And I also think that if you've used a system like Git for any amount of time, you will understand that having the history of your data at your fingertips is about more than simple backup. Like with Git, you have your entire history of your code base at your fingertips, and it's fast and reliable. You can find information, and you use it for more than just backup, right? You can use it for experiments by creating new branches where you speculatively apply some changes. If you like them, maybe you commit them back to master. You can go back in time to look at what happened at a certain date. If you find a problem in your code, you can run tests against your code like through time traveling, and it can help you identify where the problem occurred and all kinds of interesting stuff that you can do simply because the data is there. Git didn't delete all your data for you. And Datomic offers this model for your database, your production data. So imagine you create some new feature that tracks behavior over time, then all of a sudden, all the existing production data is available for you to test with. So there's many interesting applications of historic data, and I'll show you a few examples from my work later. So this is Rich Hickey. He designed Datomic, and he also designed Clojure, the programming language. So who here has heard about Clojure? Okay, good. So one of his stated goals was to design a database that breaks free from limitations of 40 years ago. So most of the databases that we use today were designed during the 70s, And while there were many great things that happened during the 70s, like especially in the prog rock scene and also in the computer science area, the hardware back then really was something different than what we have today. So Datomic is an attempt at designing a modern database for modern computers. And this is basically how it's built up. So at the bottom, you have the storage service. And Datomic innovates on the database design, but it doesn't necessarily innovate all the individual pieces. So storage is handled by existing solutions. You store your actual data. With the free version, you store it on disk using a Hibernate H2 database on the local file system. With the Pro or the paid version, you can store data in React or Cassandra, Amazon DynamoDB, and pretty much any SQL server out there. And Datomic does not store your data in a database format that way. It just uses the database like a database would use the file system. It stores just blocks of data inside those. But that allows Datomic not to worry about disk persistence, which is already a pretty solved problem. On top of that, Datomic runs one of its two most central pieces, which is the Transactor. The Transactor is what you would think of as a traditional database server, except that it only handles writes. That's all it does. The Transactor has nothing to do with queries or any attempts of retrieving information from your database. And this design allows you to scale the write part of your database independently from the reads. So you can have long-running queries that will not hamper your ability to process transactions. The Transactor is interesting for a few more reasons. Datomic is a single writer system, so there's only ever one active Transactor running. And you cannot have any more. And this is how the Transactor delivers ACID transactions, and it handles isolation by simply processing transactions sequentially. So you pop transactions on a queue, and Datomic processes them one at a time. The blue shading on the box here indicates that you can have a standby transactor. So you can actually have two transactors going, but only one of them are going to be active. The other one is for high availability. So when you want to retrieve data, you do that from a pair process. And a pair process is essentially a read-only database that runs inside your application process if you're on the JVM. So Datomic is implemented in Clojure, and it runs on the JVM. And you can basically run the database as part of your application platform process on the JVM. And the pair process is the one that's processing the queries and retrieving all the data. It builds up a cache. It builds indexes, and it does all that's needed for you to have efficient data retrieval from your database. The pair process will read directly from storage, and it will also receive updates from the Transactor. So whenever someone puts something into the Transactor, Datomic will assume that recent data is probably going to be read back, so it streams that data to the pairs. If you're not on the JVM, oh, sorry, I should mention this. If you're running multiple application processes and you don't want to pay the memory fee for each process, you can run a memcache cluster for a shared object cache. Now, because Datomic is append-only, it has an immutable data structure for all its data, so there is no need for cache invalidation in this architecture. The pair server is an alternative if you are not on the JVM or for some other reason you don't want to run the pair inside your application process. And it's basically the same thing, except that it exposes an HTTP REST API so you can talk to it. And then you will find client libraries for a multitude of languages which can talk to that HTTP API. So the examples I will be showing you here today will be with Clojure with the pair process running. If you're going to use it from some other language, it will be similar, but the actual API will be slightly different. And I would also say that the pair server is a full-featured alternative to the pair, but the pair gives you probably the best experience because it actually bolts the database into your application. That means that you can do queries and data retrieval with basically no network overhead at all, because it's all local to your process. Okay, so let's start. Is the font size readable to you guys? Okay. So first of all, I want to talk about the data model that Datomic has. And data is modeled in Datomic much like it's modeled in RDF. So in RDF, you talk about triples. You have an object, a predicate, and subject, predicate, and object. In Datomic, you have an entity, an attribute, and a value. And this thing is called a fact. So Datomic only stores facts. It's the only data type it knows about. And an entity is, in practice, just a number. It's an ID of something. And then you have an attribute, which is a closure keyword. If your language does not support keywords, it will typically be a string. And then there's some value, like this. So this is very much like RDF. And like I said, the entity is usually just an ID, or at least technically it is. Conceptually, an entity is an ID and all the attributes associated with that ID. But in addition to these three parts, Datomic tacks on two more pieces of information here. And the first one is another number, which is the ID of the transaction that created this fact. So whenever you put facts into Datomic, it happens part of a transaction, and that transaction is also an entity, which has metadata about it. And then finally, there's a Boolean at the end here, which tells Datomic whether this is an assertion, data being added, or if it's a retraction, data being removed from your database. So let's say that this was the first transaction, only inserts one attribute for one entity. If I wanted to change my name, this would look like the following in Datomic. You would have a new transaction with two facts, and there would be a new transaction ID here. And then first of all, it would remove the old value, and then it would set a new value. This is how Datomic models change at the basic level. Like for you as a developer, you would just set a new value, and then Datomic will actually create the two facts for you. So this is all you really need to know about how Datomic stores data. And we will see this again when we start talking about queries in a little while. Okay, so what about schemas? Whenever you use an attribute to store something in Datomic, you have to use a named attribute that has been defined ahead of time. So an attribute looks pretty much like this. You give the attribute a name, and then you set a type for that attribute, like so, string. And then you have to tell Datomic what the cardinality of the attribute is. And the cardinality tells Datomic that what to do when you add this attribute to an entity. The cardinality can be 1 or many. If it's 1, then writing this attribute will overwrite the existing value. If it's many, then it will keep adding to a list of values. And then there are some other things you can do as well. You can say that an attribute is unique. You can have it specifically indexed and a bunch of other things. But this is like the gist of it. Okay, so before we get into the data retrieval, we need an actual schema and some data to look at. So this is where my dietary habits come into the picture. So this is my database that I told you about earlier. So this is an Emacs org mode file, which I've been working on for 7 years. And it contains, like, for every week, like, on a Saturday, I will plan what we're going to eat the next week, and I put it in here. And then for some reason, I just kept it going, and I have lots of data. So if you go to the bottom list file, there will be like shopping lists and budgets, and it was very ambitious at some point, but now it's just meals. So I created a schema to hold this data, and I'll just walk you very quickly through it so we can have some example queries run on it. So I defined some users. Okay, I forgot to say one thing. The attributes you specify, you have to specify each attribute you're going to use. But what about the entities, like the person entity? The answer is that Datomic does not care about entities at all. So Datomic only cares about attributes. So what attributes go with what kind of entities is up for your application to decide. So in Datomic, you cannot say that an entity can only have these attributes, or it must have at least these, or this one is required, whatever. That's all left to your application. And this might seem like a weakness at first, but it's actually a strength. And it allows your schema to be flexible and grow organically over time. And also because Datomic keeps historic record of all your data, if you would add a new required attribute, how would that apply with the old ones and so on? So and another interesting aspect with this is that if you do like I've done here, I've called this users, and I have a username, like you can see here, and a user email. And then you use the namespace part of this keyword to indicate what kind of entity it is. This is similar to a table-style design in a relational database system. But the strength here is that if you have an entity that could have 100 different attributes, but most entities only have like 5 or 10, then Datomic can efficiently store that because it does not have to store nil columns, right? So you can emulate a table-style design with this, but you can also store data in a graph if you want to do that. And the same entity could have entity attributes with different namespaces, and it's really up to you. So, but I've gone for a fairly straightforward table-like design here, or that's the intention at least. So there's users, there's a group, which is just a bunch of users. Typically this is the users, the system is me and my wife, and the group is our house, and that's it. And then there are dishes, and the dish is the thing that you put on a table, like lasagna, and it's the abstract concept of the dish. And then a dish is realized by a recipe. So the reason I went this way is I wanted to be able to tell how many times have I had lasagna, but from these like 20 different recipes. So the details of this schema is not really that important. But you can tell here, here's an important attribute, recipe/dish. So this has the type of ref. And that means that Datomic will enforce that this attribute can only ever hold IDs of other entities in the database. So this is a relation that Datomic knows about. Again, it doesn't care about what kind of entities. There's only ever like one kind of entity. But it will ensure that you make valid relations between your data. And whenever you're designing relationships, there's always a problem deciding on which end of the relationship you want to model it. Do you want to have recipe dish, or you want to have dish recipes, if you follow? And Datomic makes this decision very simple because no matter where you put it, you can navigate both ways of that relationship, which I'll show you very soon. Okay, so then in my app, I also have some seed data because I started with a bunch of manual data. Yeah, not very important. Let's get on to the querying part. Okay, when you want to retrieve data from your database, if you're in a relational database, you are handed a hammer, and the hammer is called SQL queries. And you use that hammer to insert data into your database, to retrieve data from your database, and to solve logic puzzles about your data, like who is the 5th most popular eater of vegetarian food, stuff like that. You use queries for all of those. In Datomic, you have more fine-grained tools. So like we already saw, writes is handled by another process altogether. So if you think about stuff like SQL injection, if you were to ask about information from Datomic about little Bobby drop tables, he could never drop tables in your database because the writes are handled by another process entirely. But then again, even when you're retrieving data, there's different mindsets. Like sometimes you know about a thing. Like I know about this user, I want to know where does he live. And other times you want to solve like puzzles. And Datomic has queries for the latter thing, but for the first thing, there's two other APIs that are easier to work with. So, okay, this is Clojure. Apologize if you're not very familiar with it, but hopefully it's going to work for you. So first of all, you require the Datomic API. So this is the Pierre API that I talked about earlier. You can also use this from Java or any other JVM language. And then you have a connection that I made up front. So this is just a connection to my database. And to pull data, you can use the entity API here. And then you're going to pass in something really strange, which I'll discuss very shortly, and something else here. OK. So this is not very spectacular at this point. Maybe it's hard for you guys to read. OK. So what's happening here? The entity API retrieves an entity from the database, like it says. And the entity is identified by a unique attribute. So whenever you've said that an attribute can be unique, you can reference it directly like this. You don't have to know what the entity ID of this thing is. You can use a unique attribute to identify. And what is this thing that you're passing in here? Well, the connection is a connection to the transactor that your database is running. But you don't run queries on the transactor. You run queries on the client. And you have to run the queries on a view of your data. So if you remember when we looked at this, so your database is basically this part. It's just a collection of facts. And by default, it will contain all the facts ever created in your system. But before you ask for information from it, you have to define some kind of view. Because, as I told you earlier, if we have these three facts, then I only actually need one of these facts to know what the name of this person is. And the DB function here provides you a compressed view of all the facts in your database that represents the current state. And it does that at some point in time. And that point in time is exactly when I call this function. It gives you an immutable value back, which is your entire database at this point in time with the current information. I will show you in a little bit that there are other views you can gain as well to access different kinds of information. So this entity function here, it returns back to me the recipe. But it does represent that with a lazy map. So it doesn't look very fantastic right now, but we can ask it for information like, what's the variant name of this recipe? OK, something like this. What kind of dish was this? And then you can, so this is another entity that I'm getting back. So now you can lazily pull information about this entity into your process. And with the relational database, you probably would not want to go this route because you would have the n+1 queries problem, which is you're paying the network cost for every time you want to access an attribute. With Datomic, you don't do that because Datomic creates indexes that are stored in blocks in the underlying storage. And whenever you pull out one piece of fact, it's going to pull out also 1 to 20,000 other facts along with it. And if we're accessing attributes on the same entity, after you've accessed the first one, there's a good chance that the rest of them are in memory in the same process. So this actually works quite efficiently. And most of the time, when you know who you're talking about, you just want to retrieve more data about them, you can use the entity API. There's no queries involved to do that. OK, but there are also queries. So let's take a look at those. I'll get back to the other kinds of database views later. So queries are run with the queue function. And in Datomic, you have a language called Datalog implemented. Like I said initially, Datomic does not reinvent the things that it doesn't need to reinvent. And Datalog is one of those things. So Datalog comes from Prolog originally, and it's implemented here for Datomic. I'm not going to give you like a thorough explanation of all the syntax, but I will tell you to notice one interesting thing. So, here, remember I told you about the facts at the Datomic store. They look like this. There's an entity, an attribute, a value, a transaction, and whether it's being added or not. In Datalog, what you can do is to declare relationships between your facts, and then the query processor will just solve the logic puzzle and give you back everything that matches. And you do that by specifying question mark and a name to put in placeholder for values, and you can realize other kinds of values. So, for instance, I could say, give me the entity that has the recipe ID that we had before, this one. And then I don't care what transaction, and I don't care if it's being added or removed. I just want all the facts that talk about this entity and this attribute with this value. And again, you have to pass in a database to run the query against. And what it gives you back is a list of IDs that matched this thing. Okay, so that's the very basic query. Most of the time, you don't want to inline concrete values like this. So instead, you would say, here's the ID, and you would provide it as an input to the query. And when you do, I have this weird thing here, which is the explicit database argument. And what this might tell you is that if there's one database here, maybe I can put in some more databases into that same query, and that you most certainly can. Okay. Then you pass in this value from the outside. And what you achieve with this is that the query processor can cache this query in an efficient manner. So basically the same thing we had before. Okay, moving on. When you have trailing underscores like this, you can just elide them for a more readable query. Not that one. Okay. But let's take a look at, so this is basically the description of a datum or fact. And you can have as many of these as you want, and you can cross-reference variables to connect various facts. So this one has a transaction associated with it. Let's first just start by taking a look at it. So now I get two IDs, and this is the ID of the transaction that put the recipe ID on this thing, and the ID of the transaction. But like I said before, the transaction is an entity in its own right and also has attributes, so we can get those as well. And the one that Datomic creates for us is the one called DBTX instant, and this is the time the transaction occurred. Okay, so I'll call that TXI, and I'll pick that one instead. And what I'm getting back now is the ID here and the time that this thing was created. And you can see that it was created in 2011, and I just explained to you that I put this in Datomic last year. When you initially fill data into your database, you're allowed to backdate transactions. So the only thing that Datomic requires is that the time is monotonically increasing. So at the very first time you put data in there, you're allowed to backdate. But you can never put data in that is older than your newest data, if you follow. And usually, by default, Datomic will handle time for you. Okay, so that's good. Most databases nowadays typically have, or like tables in relational databases, would have an updated add and a created add attribute in their tables. In database, Datomic solves this for you. And this is basically what I showed you here. We can write this query a little bit different. I can say, okay, give me the entity that has this ID, and do not get the transaction from there. But I do want to find all the transactions that pertain to this entity. So I'm using this first fact to identify the entity, and the second one to find all the transactions that are about this entity, and then I can get the transaction instances back. And this is where this database is becoming a poor example because it really only has my initial data loaded into it. So I'm going to create a simpler database so we can play with the time aspect here. Okay. Here's another one. I have, do I have a connection? I do not. Okay, so we're now just going to create a new database. Create database, and then Datomic. And this is just going to be an in-memory database, which will be gone when I kill this REPL. This is just for demonstration purposes. But this can also be used for tests, if you want to test your code. So now I have a database. I have to create a connection for it. So I connect to that same string, like so. And then I have to have a schema before I can put data into it. So we use the transact function, con, and then it takes a list of either facts or entity maps, which are collection of attributes. So I'll create two attributes for this test. Person full name, which will be a string. Oh, string, and there will only be one. This is the one we created before. One. And we will have another attribute, which will be person email, which will also be a string. So Datomic offers a few data types that you can use, but they're not very finely grained. So you can have numbers, strings, there's a UU, ID, data types you can put in there, and a few others. But this one is a string as well. And then cardinality, and this will also just be one. And we'll make it unique by its identity. And this enables upsert behavior for Datomic. So whenever you put in data about something with an email, if the email exists from before, you will update the existing entity. If it's the first time you've seen it, it's been created. Then it gives us a bunch of information back. I'll get back to the two on top here, but the TX data here are the actual facts that were created as part of this transaction. Finally, there's a map here of temporary IDs. And this number here was not explicitly available in my transaction, but if you need to insert two entities that have a relationship to each other, you can generate a temporary ID to use within your transaction, and then the transaction result will tell you what entity IDs they were actually assigned when they were created. So that's what we can use this for. Anyway, I have a schema, so we can transact some data. Okay, I will create a person with a full name of my name and my email. Like so. Okay, so we can tell now that the ID was given here. So I can make another transaction for the same entity. I'll show you two ways to do that. The first one is to use the db add function. I will add to this entity and then set the full name attribute to my full name. That's one way of doing it. Like I said, because the email address is now unique, if I write to this thing again, it's just going to update the existing entity. So I'll just do like this. Okay, boom. Okay, now I have 3 transactions in my database, and I've created one entity and changed its name twice. You will see that the, or maybe you don't see it, but the ID here and here are the same. So let's take a look at this entity in the database now. Entity, db, con, and then here. And then we can do touch. Poof, okay. So this is what this entity looks like currently. If I perform another transaction, we will study the other result here. Like so. And then you can tell here that Datomic is telling me this is the database before this transaction, and this is the database after this transaction. So those are alternative views on all the facts that we can use for querying a database, right? So def-res is, okay. So now I can say db before, that's a Datomic DB. Okay, let's pull out the entity from that one instead. Entity here, touch. And then instead of using this database, we will use db before from the res. And then I can see that this is my old name, and if I ask the database that was created after, I can see my new name. So we're at different points in time here, and we can take a look at what the data look like. This is like your git commit log. Basically, I'm doing git checkout on my database and looking at what's inside. But now we can also take a look at the query that I did before with the transaction, because it's going to tell us something interesting now. I want the entity and the transaction where, let's see, E has user email. I'll just do this for simplicity. And all the transactions here. Oh, did something wrong. It's not called user, it's called person. Okay, so this is weird. This is one entity ID and one transaction ID. So what happened to the other transactions? Well, all my transactions only wrote to one single attribute, right? So the compressed view only has the latest one. So in order to get the rest of them, we can ask Datomic for the history database. So Datomic manages 4 indexes for us, in addition to the transaction log. So every time you commit something to a transaction, things go into the transaction log, which is the source of truth in Datomic. But they also go into 4 other indexes, and those are called covering indexes because they do not contain pointers to your data, they contain your actual data. So Datomic actually stores, when it's running, it stores all your data up to 5 times. Only one of those is required for recovery, though. And those indexes are partitioned into 3 parts. And one is the current view, and then there's the history view, and there's the in-memory view. And by default, the history view is not available because most of the time we just want the current state of the database. But you can ask for the history view, and now I'm asking all the facts. Okay. So I'm making a mistake here as well. And let me just do this. The mistake I'm making is that I am explicitly now asking for the transaction that touched the email attribute. So we're going to have to do this, that entity, any attribute, any value, and then give me the transaction. And now I get a whole list of transactions that did touch this thing. And we can use this if I wanted to know when this entity was created. I could pick up the minimum transaction. Sorry about that. Minimum transaction, which gives me the ID. If I wanted to know the time when that happened, we can do that as well. We just have to perform the join on this one again. db tx instant txi. Okay, this is when it was created. If we ask for the max, that's when it was updated. If I just want to know when was the name last updated, I can put the name in here. So like you can see, I can get all kinds of information about when things have happened to my data. Yeah, person. Sorry, thank you. Okay, and here's another thing you can do. I can figure out like what attribute changed when. So just give me the attribute and the time it changed. And you get a list of the attributes and when they changed. If I only want to know when they were added, I could add true here. And I could keep going on. And this is like a way you can rough around in your database and find historic data. And actually, the project that I'm working on now, my very first week, I used this to answer a question because someone had misused their access to an account and changed some data in their favor. And our support staff asked me, like, gee, I don't want the client finding out what happened. Can you figure out what he did? And sure, I could use this API to tell her exactly what it did and when it did it. And then we can just go and revert those changes, and everything was back to normal. So but that's the backup part of this. Another more interesting use of this is this example I will show you now. Okay, here. Can you see this? Okay, so this is from the application that we're working on. So Eventum does, they call themselves like Airbnb of event spaces. So if you need an event for a birthday or party, wedding, company outing, meeting, whatever, you can search their site for venues in your area and other criteria, and you can send requests to them. Or you can call them, and then you'll call through a proxy service that we run, and you will get access to this kind of like email thread thing. And in this app, you as the organizer can communicate with the venue owner. So here I've placed a phone call, it lasted 1 minute. I can write another message and just say, hey, did you think about our talk? And I'll send that. Oh, maybe it's not running. Okay, yeah. And you can attach files. I can make changes here. So the event is actually on the 22nd. And also, you should probably want this picture of some sort. This might not work when I'm offline. Okay, whatever. Cancel that. Come on. Okay. So basically what we do is that you can do things here. There's two parts that can communicate in various ways. And then we build like an event log down here of the various things that have happened. And the way that we implemented this, or the way that this is designed in the database, is that we have this thing which is called a booking request. And then we have a list. There's a booking request / calls attribute, which has a list of call entities, like this one that you see down here. And then there's a booking request / messages list, which is this thing and this thing. And then there's stuff like this. Like when you edit certain attributes, we display it in the thread here, like in the timeline. And all of this, we use the historic record of the booking request, like I just showed you, to build this event log. So we did not have to explicitly design any part of the time aspect of this. The time aspect is fully managed by Datomic. And I think this is a really neat thing to be able to do without having to think about it up front. So when we started this, we had not yet gotten the calls part in. So when we decided that we wanted to take phone calls through the system, we just added a list of phone calls, and voila, we could place it correctly on the timeline on all our data, both like existing and old. Another thing that we're working on now is to figure out, we want to figure out for the venue owners, what's their average response time. And that would just be a matter of taking a look at these messages when they're sent from the client and when they're sent from the venue owner, and we can do some math on the time that elapses between them, and we can answer that question. And not only for new messages coming in, but also for the entire history of our database. And I think to be able to do this is very interesting, because it means that you don't have to think about all the uses for your temporal data up front. You can figure out as you go. And this is similar to doing a git bisect to find a bug in your code, right? Like you figure out that something is not working now. I know that it was working last month. Let's just replay all the commits in between and figure out where the problems occurred. And I also saw another example from someone building a bank in Brazil. And they had improved their fraud detection algorithm, which will take a look at what cards are being used in what places and what kind of transactions typically change the amount after being used in Starbucks or whatever. And when they improve their fraud detection algorithm, they can run it on all their historic data to see if there would be any false positives or if it would catch things that they haven't catched in the past. So my point with all this is that like having all the historic data at your fingertips is really useful for a number of reasons. Okay, I'm running out of time. I showed you the history database. One thing I did not show you, but that you also can do, you can go back in time, but you can also go forward in time. So when you have a database, let's say that I get the current view of my database, you can speculatively apply changes to that database and query the result to solve problems. So I could say with, I'll just do def res here. And so with this database, please apply this transaction data, person, full name, Bob. And then we could pick up the entity, for instance, from DB after salt, and then person, email, shouldn't have such a long name. Okay. Okay. And this is this API here with can be useful for we use it in our production code, but the easiest example to understand is to use it in tests, right? So in our tests that touch the database, we could create an in-memory database, load it with the schema, and then just use with to speculatively apply a bunch of changes, run some code, and see what happens. Okay, what if the data changes this way? What will happen then? And yeah. So there's a way for you to go both forward in time and backwards in time. And there's lots of other things that I didn't have the time to show you, but you can take a look at for yourself. The last thing I want to say is that are there anyone here who's using, working on front-end web applications? Have you used like React or Redux or stuff like that? Yeah. So this is a page from the Redux documentation which talks about normalizing state shape. And it shows you that sometimes your state looks like this. Basically a big nested JavaScript object of data. And the clue here is that lots of this data is duplicated throughout the payload. And then they suggest, or first of all, they say that this might be a problem, and I wholeheartedly agree. But then they say that maybe this could be the solution. And that's where I kind of fall off, because here they are suggesting that you hand roll a relational database system in JavaScript, which is probably not what you want to do. What you can do instead is to use Datascript, which offers you the entire Datomic model on the client. So I don't have any spectacular example for you right now, but there's only one but, and that is that Datascript does not have the historic view of data. And that's because it's running on the client, perhaps on your phone, where you wouldn't want to use unlimited memory. But it offers you the same data model and schema possibilities, and you have the full query engine at your hands, and it's really, really fun to work with. And you can use it from JavaScript, you can use it from ClojureScript or whatever. I really suggest you take a look at it if you work on front-end JavaScript projects. In the example I showed you here, we serve a Datascript database over an event, what's it called? Event source? Event stream, sorry, event stream. Yeah. Server-sent events. So when you load this page, we send a Datascript database over server-sent events. And whenever something happens on the transactor on the server, we calculate what changes you need for your client database, and we ship it over. And it's been a joy to work with. So that was it. Hopefully, you now have some idea of what Datomic does and how it might work for you. And maybe, like I did when I first started working with this, maybe you'll realize that this database solves some problems you didn't even realize that you had before you saw it. So yeah, I hope you enjoyed it, and thank you for your attention.